Hello and Assalamualaikum. Today I'm gonna present about photon energy. Photon energy definition is the energy carried by a single photon. The amount of photon energy is directly proportional to the photon's electromagnetic frequency, and thus it is equivalently or is inversely proportional to the wavelength. The higher the photon's frequency, the higher its energy. Equivalently, the longer the photon's wavelength, the lower its energy. Photon energy can be expressed using any unit of energy. Among the units commonly used to denote photon energy are the electron volts and the joule, as well as multiples of the joule itself, such as microjoule. 1 joule equals 6.24 multiplied by 10 to the power of 18 electron volts. Therefore, the larger units may be more useful in denoting the energy of photons with higher frequency and higher energy, such as gamma rays, as it opposed to lower energy photons, such as those in the radio frequency region of the electromagnetic spectrum. In physics, photon energy is directly proportional to frequency, where E equal hv, but sometimes frequency of radiations can be written as f, giving expression E equal hf, where h is the Planck constant. In addition, E equal hc over lambda, which is the E is the photon energy itself, lambda is the wavelength, c is the speed of light, and h is the Planck constant. In electron volts, basically energy is often measured in electron volts, whereas to find the photon energy in electron volts using the wavelength in micrometers. The equation is approximately E equal 1.2398 over lambda multiplied by micrometers. The equations only hold if the wavelength is measured in picometer. The photon energy at 1 micrometer wavelength, where the wavelength of near-infrared radiation is approximately 1.2398 electron volts. The applications of the photon energy, whereas the first is the frequency modulation radio. At 100 MHz, it emits photons with an energy of about 4.1357 multiplied by 10 to the power of -7 electron volts. Secondly, the very high energy gamma rays. It has photon energies of 100 G electron volts over 1 P electron volts, which is a quite high frequency. And lastly, photosynthesis, which specific chlorophyll molecules to absorb red light photons at a wavelength of 700 nanometer in the photosystem.
Assalamualaikum and hi, my name is Muhammad Zohiruddin bin Khairuddin, metric number S60977. Today I will present a photoconductive effects. In the photoconductive effect, electrons are emitted from a material when light is incident on its surface. Ordinarily, an electron is bound to the material and cannot escape from it unless energy is supplied. The light must supply each emitted electron with sufficient energy to escape from the surface. To be emitted from the surface, an electron must receive a minimum amount of energy F, called the work function of the surface. The value of the work function depends on the material and on the condition of the surface. For example, the work function for aluminum, which is a clean anodized surface, is 4.2 eV. The photoconductive effect has three important characteristics that cannot be explained by classical physics. First, the absence of a lag time. Second, the independence of the kinetic energy of photoconductive on the intensity of incident radiation. And third, the presence of cut-off frequency. Let's examine each of these characteristics. The absence of lag time. When radiation strikes the target material in an electrode, electrons are emitted almost instantaneously. Even at very low intensity of incident radiation, the absence of lag time contradicts our understanding based on classical physics. The intensity of incident radiation and the kinetic energy of photoconductive. The photocurrent is plotted versus the applied potential difference between the electrode. From the positive potential difference, the current steadily grows until it reaches a plateau. Furthering the potential increase beyond this point does not increase the photocurrent at all. A higher intensity of radiation produces a higher value of photocurrent. The presence of a cut-off frequency. For any metal surface, there is a minimum frequency of incident radiation below which photocurrent does not occur. The kinetic energy of photoconductive at the surface grows linearly with the increasing frequency of incident radiation. Advantages and disadvantages. The advantage of a photoconductor. These are cheap and available in different sizes and shapes. They need less power and voltage for their operation. These are used to make simple circuits. The disadvantage of photoconductive. Once applied voltage increase the maximum voltage, then it will cause damage to the photoconductor. Second is its response time is very slow, like 10 seconds or 100 milliseconds. Third is it is sensitive to temperature. And last is these characteristics are non-linear. In a conclusion, the maximum kinetic energy of a photoconductive at the metal surface is the difference between the energy of the incident photon and the work function of the metal. The work function is the binding energy of electron to the metal surface. Each metal has its own characteristics work function. Thank you. That's all for me.
Thank you, Zoe. Now let's talk about photovoltaic effect. Photovoltaic effect is the process that generates voltage or electric current in the photovoltaic cell when it is exposed to sunlight. The photovoltaic effect was first discovered in 1839 by Edmund Becquerel. When doing experiment involving cells, he noted that the voltage of the cell increased when a single phase was exposed to the sunlight. This is a symbol of photovoltaic effect. How the process works? When a photovoltaic cell is subject to the sunlight, the absorbed amount of light generates electric energy, while remaining sunlight can be reflected or passed through. The electrons in the atom of the photovoltaic cell are energized by the energy of the absorbed light. With this energy, these electrons move from their normal position in the semiconductor photovoltaic material and they create an electric flow that is electric current through an external electric circuit connected to the photovoltaic cell terminal.
Let me tell you a little bit how the solar PV works. Sunlight is made up of tiny packets of energy called photons. These photons radiate out from the sun and about 93 million mass later, they collide with a semiconductor on a solar panel here on Earth. It all happens at the speed of light. Take a closer look and you can see the panel is made up of several individual cells, each with a positive and a negative layer, which create an electric field. It works something like a battery. So the photons strike the cell and their energy frees some electrons in the semiconductor material. The electrons create an electric current which is then harnessed by wire connected to the positive and negative sides of the cell. The electricity created is multiplied by the number of cells in each panel and the number of panels in each solar array.
What is the advantage and disadvantages of photovoltaic? The advantages of photovoltaic is first, environment-friendly energy. Second one, reduce your energy bill. And third one is infinite energy. The disadvantages of photovoltaic is, the first one is seasonal energy, second one is installation requirement, and the third one is location sensitivity. The conclusion of photovoltaic is, the photovoltaic effect can be defined as being the appearance of a potential difference between the two layers of the semiconductor slide in which the conductivities are opposite, or between the semiconductor and a metal under the effect of the light stream.
Next, what is the difference between photoconductive effect and photovoltaic effect? First one is definition. Photoconductive effect is the emission of electrons from the surface of a substance in response to the incident light, while photovoltaic effect is the process in which two dissimilar materials in close contact produce an electrical voltage when struck by light. The second one is electron emission. Electrons are emitted in a photoconductive effect, while electrons are not emitted in a photovoltaic effect. The third one is electric current. An electric current is not generated in a photoconductive effect, while an electric current is generated in a photovoltaic effect. And the last one is energy required. Photoconductive effect takes place when the energy provided by the photons is enough to overcome the electron binding energy, while photovoltaic effect is happen when the energy provided by photons is enough to overcome the potential barrier of excitation.
So that's from us. Thank you.